Hello students! Today we will learn how to multiply two binomials together. So if you look at this first example, this is an example of multiplying two binomials together. There are 1, 2, 1, 2 terms in each of the parentheses. So there are going to be two ways that we can do this, and I'll show you both ways. Before we start though, it's important to remember what we learned last time about multiplying single terms together, or monomials. So write yourself a little note if you need to. When multiplying monomials, or single terms, remember how that works. We multiply the coefficients, the numbers in front, and we add the exponents. So we're going to be doing some of this when we're multiplying binomials. So make sure that you remember this. So we multiply the coefficients and we add the exponents. Okay, so when you're multiplying binomials, this is how we do it. We are going to be distributing because there are parentheses, but we're going to be doing something called double distributing. Double distributing. We can also use an acronym that helps us, and it's called FOIL. And I'll explain what that means. So the F stands for first, the O stands for outer, the I stands for inner, and the L stands for last. So I'm going to show you how to do these two methods, and you're going to be able to decide which method you prefer. But the big thing to remember is that we're doing something called double distributing. Basically, each term in the first parentheses gets multiplied by each term in the second parentheses, which is going to produce 4 resultant terms. So for this first one, I'm going to show you both methods, and then I'm going to let you decide which method you prefer. Okay? So the first method we're going to do is the FOIL method. First, outer, inner, last. If I'm double distributing, I'm taking the first term from the first set of parentheses, and I'm going to multiply it by the first term in the second parentheses. Then I will take the first term in the first parentheses times the second term in the second parentheses. Once I'm done with that 2x, then I'll move to the -3, and I'll multiply it by the first term in the second parentheses, and then I'll multiply it by the last term in the second parentheses. So we're multiplying 4 times. Now the FOIL for FOIL are like this. We'll first multiply the 2 first terms in both parentheses. That's the 2x times the x. Now if you want to add the little exponents there on the 2x and the x, just so that you remember, that will help you remember to add those exponents when we multiply. So 2x times x is 2x squared. Remember, you've got to add those two ones together. So that's the F, the first terms of both parentheses. The O stands for the 2 outer terms. That's the 2x and the 1, the 2 terms that are on the outside. So we'll multiply 2x times 1, which is just 2x. Okay, and it's a positive 2x. The I stands for inner. Those are the 2 inside terms, the -3 times the x. -3 times x is -3x. And then the L stands for last. those are the two last terms, so the negative 3 and the 1. Negative 3 times 1 is negative 3. So it goes like this. Let me just show you one more time. First, outer, inner, last, in that order. Now, if you do it in this order, many times the two resultant terms in the middle will combine. Notice we have 4 terms, 2x squared, 2x, negative 3x, and negative 3. Many times the O and the I, or the two inside terms, will be like terms and they can combine. Notice they both have 1x, so we can combine them. So 2x and a negative 3x are going to combine to make a negative 1x. And then we'll bring down that minus 3 and that 2x squared. And this quadratic trinomial is what you get when you multiply those two binomials together. So that's one method. The other method takes up a little more room on your paper, but it's really great for organization. So a lot of students like this. Now, later in biology, you're going to learn about Punnett squares, and it's kind of like a Punnett square. So if you're not familiar with that, it's basically a 2 by 2 square, okay? And we're going to write one binomial on the top, and we're going to split the two terms up. So we'll put 2x here and the minus 3 here. So I'm just taking that very first binomial, the 2x and the minus 3, and splitting them up. The second binomial, I'm going to put on the side. I'm going to put one term at the top, the other term at the bottom. Okay? So here's how it works. Think of like a multiplication table. You're multiplying the row and the column together. So in this first box, right here, we're going to multiply the 2x and the x together because that's where they meet. And remember, we can always add the little exponents on our x's. 2x times x is going to be 2x squared. So basically, that's the first term over here, right? We're just getting it in a different way. In the top right box, we're multiplying negative 3 by x. Negative 3 times x is negative 3x. And notice, on the left side, that's this term here. All right, now we're to the bottom row. The bottom row, we're going to multiply 2x times the 1. Well, anything times 1 is itself, so 2x times 1 is 2x. That's this term over here. And then in the last square, we'll multiply negative 3 times 1. Negative 3 times 1 is just negative 3, which shows up over here on the left. So we still have the same 4 terms inside of our box. We just got them using a different organizational method. So you get to choose which method you like. Now remember over on the left, the two middle terms combined, that 2x and that negative 3x, right? Well, if you do your the box method, those two terms are usually these two terms on the diagonal. And those will usually be like terms, and you'll also be able to combine. So when you combine those, that's where you get that negative x. And then you've got the negative 3 from that lower right box and the 2x squared from the upper left box. This is just another way to get the same answer. Notice these two answers are identical. Okay, so kind of figure out which way you like. You might want to see another example before you decide. Okay, this example doesn't quite look like two binomials being multiplied together. Basically, this is a binomial that's being squared. Well, when you square something, you multiply it by yourself. So this literally means 3x minus 4 times 3x minus 4. So I'm going to expand it so that we can see the two binomials. It's kind of like they're hidden. This looks more like the first example. Okay? So I'm going to go ahead and I'll show you once again the two methods so you can decide by yourself. So for the first method, we're going to do first, outer, inner, last. And sometimes it helps to write the FOIL until you get the hang of it. So 3x times 3x, and remember we can put our exponents of 1 on our x's. 3x times 3x is 9x squared. Remember, multiply the 3's, add the 1's. 3x times negative 4 is going to be negative 12x. Negative 4 times 3x is also negative 12x. And then negative 4 times negative 4 is positive 16. Remember what I said, usually 99% of the time these two middle terms will be like, and you can combine them. Negative 12x and another negative 12x makes negative 24x. And then we'll bring down the other two terms, the last term of 16 and the first term of 9x squared. So this is what you get when you multiply those two binomials together. Now let's try the box method. So for the box method, we're going to put one binomial on the top and one binomial on the side. It really doesn't matter which is which, but since these are identical, it definitely doesn't matter. 3x and negative 4, 3x and negative 4. So whatever this sign is between the two numbers, remember that is going to stick with the last term. So that negative is going to stick with the 4. So you'll put it with the 4 on both of these. Now let's go ahead and multiply. 3x to the first power times 3x to the first power is 9x squared. 3x times negative 4 is negative 12x. 3x times negative 4 in the lower right is also negative 12x. And then negative 4 times negative 4 is positive 16. Remember, when you do it this way, those two like terms will usually be on the diagonal. So those are usually the two that you'll be able to combine. Negative 12x and negative 12x combine to make negative 24x. And then we'll bring down the bottom right and the top left. Notice either way you do it, you still get the same answer. So it's really up to you how you want to organize it. Let's try another one. So for this one, what I would like for you to do is choose one of the methods. Okay, I think I'm going to try to I'll do the box method for this one. Okay, I'm just going to do one method. If you want to try the other method and make sure we get the same answer, you can. So I'm going to put x and negative 7 on one, either the top or the side, and then x and positive 7 on the other. Notice these binomials are almost identical. The only difference is this negative and this plus. Now when that happens, you're going to see something special. So watch out for something special to happen. All right, I'm going to put my 1's for my exponents on my x and go ahead and multiply. X times x is x squared. We add the two 1's. X times negative 7 is negative 7x. 7 times x is positive 7x. And 7 times negative 7 is negative 49. Okay, usually remember those two on the diagonal can combine. A 7x and a negative 7x, though, are opposite. So they're going to add to make 0. They're going to actually go away. So all that we're left with is x squared and the negative 49. Usually when you multiply two binomials, you get a trinomial, 3 terms. But if your binomials are almost the same, except you have a negative and a minus as the only difference, you will end up with a binomial as your answer. And this is actually a special type of binomial. It's called a difference of two squares. Difference of two squares. Difference meaning there's a minus in the middle. There will always be a minus there. Okay? Two squares meaning the first term is a square. X squared is the square of x. And the second term, the 49, is the square of 7. So it's the difference of two squares. All right, let's try another one. Okay, so if you're starting to get the hang of this, feel free to pause and try these and then unpause and see if you get the right answer. Otherwise, you can stay on with me and we can work on this together. For this one, I'm going to do the first method. I'm going to do the double distributing FOIL method. So we'll do first, outer, inner, last. First, outer, inner, last. Okay. And then, of course, if you want to put the ones on your x's to remember to add those ones together. All right, let's do the first. 3x times x is 3x squared. The outer, 3x times negative 5 is negative 15x. The inner, negative 2 times x is negative 2x. And the last, negative 2 times negative 5 is positive 10. Remember, we can usually combine these two middle terms, negative 15x and negative 2x, combine to make a negative 17x. Bring down the 10, bring down the 3x squared. Boom, there is your answer, your simplified version. Let's try a few more. Let's go ahead, let's try the FOIL method again. First, outer, inner, last. First, outer, inner, last. Of course, if you want to try the other method and just make sure we get the right answers, that's fine. If you want to pause and try it on your own, that's great. All right, for the first, and I'm going to put my exponents of 1. D times D, D squared. Outer, D times negative 5, negative 5D. Inner, 2 times D, positive 2D. Last, 2 times negative 5, negative 10. Let's combine these two middle terms. Make sure they're like. They are. Negative 5D and positive 2D will combine to make negative 3D. And then we'll bring down the negative 10 and the D squared. So this is the trinomial you get when you multiply these two binomials together. All right, here's another one. Again, feel free to pause it if you'd like. I'm going to go ahead and do the box method this time just to kind of change things up a little bit so you can see it from both ways. One of my binomials is negative 3b and negative 4. My second binomial is 2b and positive 6. I'm going to put my exponents of 1 on my b's so that I remember. Let's go ahead and multiply. In the upper left box, negative 3b times 2b is negative 6b squared. Upper right, 2b times negative 4 is negative 8b. Lower left, negative 3b times 6 is negative 18b. Lower right, 6 times negative 4 is negative 24. Look at the two terms that are like on the diagonal. They should be like. Negative 18b and negative 8b are going to combine to make a negative 26b. And then we'll bring over our other two terms, the negative 24 and the negative 6b squared. All right. Okay, so these last two are just extra. I'm not going to do them with you. You're welcome to try them. So we did multiplying binomials, but you can apply that to multiplying a binomial times a trinomial, like number 7, or a trinomial times a trinomial, like number 8. All you would do is you would just do more multiplying. So for 7, you would do something like this: 2x times the 3x squared, 2x times the 2x, and then 2x times the negative 5. Then you'd move on to the 3. 3 times 3x squared, 3 times 2x, 3 times negative 5. So you're going to end up with 6 terms. And then, of course, you'll want to combine any of them that end up being like. If you were to use the box method, you would make a 2 by 3 box. So you would do something like this. So you could say 2x and 3, and then 3x squared, 2x, and negative 5. And you can do something similar, right, with the other one. You're going to be multiplying 9 times on number 8. So if you want to try those, go ahead. I'll put the answers here. So if you're curious, these are the solutions. Remember, you're going to have more terms than these. This is after the like terms have been combined. But don't stress about 7 and 8. Make sure you can do binomial times binomial. All right, bring your questions to class. See you in a little bit.